The root test is one of the more specialized tests that is used to determine the convergence of an infinite series. You can usually spot these in a particular problem because oftentimes the term in the series that you're adding up will usually be raised to an nth power, so they're usually pretty easy to spot. But here's what it says. The root test says that your series converges absolutely if the limit as n approaches infinity of the nth root of the absolute value of a sub n is less than 1. It'll diverge if that limit's greater than 1, and you can't use this test if the limit equals 1. Now let me explain just a couple things about this. First of all, the word converges absolutely. If you remember in the ratio test video, we talk about the difference. Here's a quick reminder of absolute convergence versus conditional convergence. Assume that you have a series that converges. If you can take the absolute values of those terms and that also converges, if that still converges, then we say it converges absolutely. Because what happens is sometimes a series will converge, but only because it has alternating terms, positive and negative, and the negatives and the positives cancel out so much you do get convergence, but only with the help of it alternating signs and whatnot. So by taking absolute values, you basically take the help away from it. So if it converges absolutely, it's a very strong type of convergence. Here's an example of one, just so you can kind of wrap your head around it. Negative 1 to the n over n cubed. Clearly this converges a lot of different ways. Alternating series test, to take your pick. There's a lot of different ways. Ratio tests would show that converges. Now, that definitely converges, but what if you took the absolute value of these terms? Well, in effect, the n cubed would stay n cubed, but the minus 1 to the n, the plus 1, minus 1, plus 1, minus 1 would always be a plus 1. So if you had this series 1 over n cubed, that would still converge by p-series test. So this type of original series converges absolutely. And on the other hand, take a series like this, sum negative 1 to the n over n. That converges, yes, again by ratio test or whatever test you want to use. Alternating series test will be fine. But if you took the absolute value of these terms here, and got rid of that negative 1 to the n, and then you're taking the sum of 1 over n, that would diverge by p-series test. So this is a weaker type of convergence. So anyway, what the root test gives you is absolute convergence if it holds true. Now let's look at the inside of this. What's up with the limit as n goes to infinity of the nth root stuff? Well, basically what you're doing here, the root test, the nth root will basically get rid of or not examine any of those nth powers that were in the original series. And then you get down to the root of just analyzing the meat of the series, whatever is inside that nth power or whatnot. And if those terms, if that limit is less than 1, then it's going to converge. And if that limit's greater than 1, it'll diverge. So let's look at a couple examples here. Here's a easy one just to get us started. If you were handed this series and somebody simply said, figure out whether this converges or not. All we would have to do is look at this nth power to realize that this is a root test and not one of the other tests. That nth power is usually your dead giveaway that it's the root test. So I'm going to take a limit. Now rather than writing the nth root of such and such to the nth power, let's just go ahead and agree that those are going to negate each other or cancel each other, and we'll get the absolute value of negative 3n over 5n plus 1. And I'm going to forego a little bit of the algebra. This would give you infinity over infinity, but after using L'Hopital's rule, which you can watch a video on that, L'Hopital's rule, you would get 3/5, and that's less than 1. That's a good thing, because if that limit is less than 1, you basically got this case here. I took the nth root and then of the nth power, and that limit was less than 1. So this series right here converges absolutely by the root test. So that's how it's used, and it's a pretty dead giveaway based off of that nth power there. Let's look at one more. If you were handed this series here and someone said, does this converge? Well, we'd have a pretty good idea of what test to use, again, because of this nth power and this n and the exponent here. Now, a lot of these will have e to the such and such n. To handle that situation, just remember one of your rules. If you have x to the a times b, then that's the same as x to the a quantity raised to the b, because when you have a power to a power, you can multiply those two guys. So what I'm getting at here is that this term right here could be expressed a sub n equals, let's see, you could do e to the -3 raised to the nth power. We could pull that n into a higher exponent here. So these are the same because you would multiply those exponents to get back to where we started, over n to the nth. So if we take the limit as n goes to infinity, absolute value, nth root of these guys that have an nth power, let's just go ahead and remove those nth powers. We'd have e to the -3 over n. E to the -3 is a constant. You could write it 1 over e cubed, e being around 2.718. It's a transcendental number. It's a constant that never changes. So n's the only variable we have here, and as n goes to infinity, this will go to 0. I'm not interested in the fact that it's 0. I'm interested in the fact that it's less than 1. That's really the big deal. So this one converges as well. This converges not just any old convergence, it actually converges absolutely by the root test. So for both of these examples, they happen to converge, but there are plenty of examples where this limit will be greater than 1. We'd say that it would diverge. And then if it happened to equal 1, then what you would have to do is go back to another test, and you'll just have to find one that fits the particular problem, whether it be who knows, integral test, or there's really no way to tell. It's one of your limit comparison or direct comparison tests, perhaps, maybe nth term test. It just kind of depends on the problem.